Hi, my name is Todd from the Strathmore Woodworks, and in this video we're going to cover how you can use the Woodpeckers Saw Gauge to check the alignment of your saw blade to make sure that it actually runs parallel to the miter slots on your saw. This is vitally important if you are interested in making straight cuts, and we'll show how if the blade is actually out of alignment, you can create some serious problems for yourself, including potentially causing kickbacks. So if you own a table saw, or if this is interesting to you, stick around for the rest of the video. By far the biggest problem you're going to have if your table saw blade isn't aligned with your miter slot is you're just not going to be able to get perfectly straight cuts. Now you may say to yourself, or say, hey Todd, I use a square to align my miter gauge with my table saw blade to make sure it's perfectly 90 degrees. So when I do a cut, I'm going to get a perfect 90-degree cut, or of course whatever angle that you're actually cutting at. And while using a square to get your miter gauge squared up with your saw blade is better than nothing, it still doesn't fix the problem. Let's look at the geometry of that real quick to show you why. All right, so here what we've got in our shop notebook is a quick diagram of a table saw. We've got our two miter slots. We've got a saw blade, and the saw blade is out of alignment, and obviously we've exaggerated that quite a bit. But for example, as we said just a second ago, if you take a square and go ahead and align your miter gauge with that, and we'll draw in our miter gauge, and then you go ahead and make a cut. So you've got your piece of wood against there. The cut is going to be made at that leading edge of the table saw, and the piece of wood is going to go straight up into the table saw. And what you're going to find is that because the piece of wood is canted compared to the direction that it's moving in, you actually get a cut that is not straight. So unless the miter gauge is actually straight to the table saw, there's just no way to get a straight cut. All right, the second problem you can have, among many, if you've had problems with getting burn marks on your wood as it's going through your saw blade and as you're cutting it, you've checked everything else, you really can't figure it out, and given some woods just tend to burn easier than others. But if the rear of the blade is canted over towards the fence, what you can actually be getting is the wood makes the initial cut of the front of the blade, and as it's going through the rear of the blade, it's still making contact. These teeth really shouldn't be making contact with the wood at that point, and that can cause some burning. The third problem you can have, which is much more serious, is depending on that angle between the saw blade and the fence, you can actually get some pinching of the wood, which can cause kickback, and we've all seen the results of something like that. But effectively what happens is the saw blade is pinching the wood between the fence, and those teeth on the way out are going to lift up that piece of wood and throw it at you. Nobody needs that. So for those reasons alone, it's a good idea to check the angle between your saw blade and miter slot. So next, let's go over setting up the tool. Okay, so for making this measurement, we need to set up our saw gauge. In this case, we've got a Woodpeckers Saw Gauge. I like it a lot. Definitely not sponsored. It just has a few parts here. There's two 1/4-inch pins that set in the miter slot. There's the cradle that sits on top of the pins, and then the body, which includes the gauge, the plunger, and you've got these slots on the bottom that fit over the cradle. Let's set this guy up. It's pretty easy. You just take the pins and drop them in each side of the miter slot, and the cradle goes on top of this. You'll notice that these are milled out to fit the pins. There we go, very nice. The thing that is really cool about this is that no matter how wide the miter slots are, or if there's maybe a little bit of variation front to back in the miter slots, these two pins expand or contract within the slots. The cradle pushes them to the edge, and of course as you move this through the slot they push back, but it keeps the cradle always in the center of your miter slot no matter what, which is really important as you make your measurement. And then after that, your gauge just goes on top of that. Again, it's milled out to fit that gauge fit that gauge really well. And that's all there is to it. You select the spot on the gauge depending on the distance between the miter slot and your saw blade, but that's about it. Super simple. Okay, so we're all set up to actually take our measurement. First, your saw blade should be raised all the way up, and then we need to pick a spot on the saw blade to actually take our measurement from. I've seen some tutorials and then the instructions for the guide here. They suggest taking the measurement from a sawtooth itself. I'm not real wild about that. If the sawtooth side of it is exactly perfectly flat, then fair enough. But the issue is that the end of the plunger is rounded, and if there's a bevel to that sawtooth, getting the plunger dead in the exact same spot front to back can be an issue. So what I prefer to do, and as you've seen, or as you can see, I've already taken a Sharpie. I mark a spot on the saw blade just behind the sawtooth that I want to take a measurement from, and then we can go ahead and do that. And as you can see, I've already set up so it's spot on here. And next, and I'll take a photo of this, take a picture of the measurement. You should be writing this down in your shop notebook because you have a shop notebook for taking notes. But in this particular case, I had previously adjusted the indicator here. So it's effectively right at 0.2 of an inch. So next, we're going to measure the back side of the blade. Now here's where I do it a little bit differently, or actually a lot of bit differently than what the instructions would have you do. The instructions for this guide have you just leaving the saw blade in position and just swiping the gauge to the back of the blade. I'm not wild about that because we want to measure just the slot versus the angle of the blade. If you don't rotate the blade to measure the exact same spot, then what you can include in your measurement, or end up including in your measurement, is any warps in the blade, if the finish isn't exactly uniform across there. So for example, for your blade, if you've overheated it in the past or something else has happened to it, and that's slightly warped, then if you don't measure the exact same spot, you just measure it in the same position front to back, then you can be including that warp in your measurement. You don't want to do that. Same thing for any variations in it, whatever it may happen to be, some pitch buildup on there and whatnot. You don't want to include that in your measurement. So what you want to do is, like I said, take that same spot, rotate it to the back, and take your measurement again. And let me take a shot of that so we can put it up on the screen. And how about a better one? All right. Now, and it's really that simple. So let's go over the results. All right. So you've made your measurements. You've recorded them in your shop notebook. Where do you go from here? Well, in my particular case, the front measurement and the rear measurement were both 200,000th or 2/10 for a difference of 0. Now, that shouldn't be a big surprise because this is not the first time I've done that and spent quite a while adjusting the top of this when I first received the saw. So I suppose, if anything, that shows you the how fine you can get the adjustment with this particular tool. What should your target be? Target should be about 3/1000ths of an inch or less, difference between the front and the back. If it's less than that, then you can decide whether you want to try and adjust it or not. You know, you might end up kind of chasing your tail for something less than 3/1000ths. If it's over that, you really should think about, all right, digging into the manual, how do you, how you make that change and go ahead and doing it. But say, for example, say your difference isn't 0. What do you do and what does it mean? So in our first example here, say, for example, your front measurement is 150/1000ths and your rear measurement is 200/1000ths. Using our little diagram here, this being the 2 miter slots, saw blade, what that would mean is that the distance between the front of the blade and the miter slot in the front is less than the distance of the rear of the saw blade in the miter slot in the back. And the only way for that to happen is if relative to the table, the saw blade, the rear, is canted towards the fence. That's probably the last thing you want, because as we talked about before, what that means is potentially that piece of wood is being sandwiched or pinched in between the rear of this blade and your fence. You don't want that. And if you see, and of course, if that value is negative, that's telling you, anytime you see a negative value, if you're subtracting the back from the front, negative value means you're pinching or potentially pinching your wood back there. Likewise, in the second example here, say you measured 150/1000ths distance in the front and 100/1000ths in the back for a distance of positive 50/1000ths, that would mean your blade is, the rear is slightly canted away from the fence. If you had one to choose, that would be it. And if I was less than 3/1000ths of an inch with a positive number, I probably might leave it right there. So there you go. If you enjoyed the video, maybe a thumbs up, maybe a subscribe. Otherwise, have a great day.